Alright everyone, so I'm going to continue talking about the atom. I didn't get quite all the information I wanted, and I know I put a lot of information in that first video, so I'm just going to continue on. So with that last video on the atom, I ended by talking about the valence electrons. So just a quick recap, the valence electrons, let's say this is the nucleus, they circle the nucleus. Now you have shells that circle the nucleus, and the valence electrons is the outermost shell. So let's say we have two shells, and then this shell has the valence electrons. And once that outer shell is complete, the atom is happy. And so let's scroll back down to my periodic table. And so I said that the shells follow the trend of the periods of the periodic table. And so with each line you go down on the periodic table, the addition of each shell comes. So with the periodic table you have periods that go this way, and you have columns that go this way. So what happens is with each column you will gain an electron to the shell. So if we go over here, we have +1 charge, then we have +2, +3, plus or -4, -3, -2, -1, and 0. Everything wants to be like these noble gases, which run across this column of the periodic table. And so when it comes to carbon, it needs to gain 4 electrons because it's 4 spots away from being at the state of neon. Now, I discussed before that nitrogen is 3 spots away, so it'll gain 3 electrons. Now, let's take a look at lithium. Lithium is only 1 spot away. Now, you would think at first lithium is, oh my goodness, look at how far lithium is away. But lithium is not actually that far. It's really close to helium. So lithium currently has a shell, and it has 1 valence electron in this shell, in the valence shell. So what it will simply do is it'll just give up that electron. So we have the electron leaving. And then this shell is gone completely, and it has a complete shell. So when lithium has 1 complete shell, it acts just like helium. And so when it's just like helium, it has reached a noble gas state. We will also refer to this as the octet rule, because if you notice, each period has 8 elements, except the first one. Helium has 2 electrons in its valence shell. Neon has 8. Argon has 8. Krypton has 8. Xenon has 8. Radon has 8. So 2, 8, 8, 8, 8, 8. Can you see why we call this the octet rule? Everything wants 8 electrons in its valence shell. And helium, just being weird and different, wants only 2, but it makes it happy. And so that's where the plus charges come from. Now if you look at magnesium, it is 2 electrons away from neon, so it will give up 2 electrons to be like neon. And that's where the +2 charge comes from, because it gave up 2 electrons. Now I'm going to quickly go over a new part of the atom. So we've already talked about the electron cloud, we've talked about protons, neutrons, and electrons. But let's talk about the isotopes. So isotopes are when elements of the periodic table have different numbers of neutrons. If you change the number of protons, then you change the element. Because hydrogen has 1 proton, if you add a proton to it, it becomes helium. But if you change the number of neutrons, then you can get a isotope. Now, I'm sure that you guys have heard of carbon-12 and carbon-14 because carbon-14 is a form of dating because carbon-14 dissociates into carbon-12. And so what we're going to now look at is carbon-12 and carbon-14. Carbon must have 6 protons and 6 electrons. So even when in carbon-14 it has 6 protons and 6 electrons. This is the mass number. This is another mass number. So this carbon is heavier than this carbon. So what this change in mass number is an addition of neutrons. So what we simply do is take 14 minus 6, and then we have the number of neutrons. This just so happens to be 8 in carbon-14, while carbon-12, on the other hand, has only 6 neutrons, because 12 minus 6 equals 6. And so, this is what we call an isotope. Many elements have isotopes. When you look at these numbers down here, the reason why nitrogen isn't just nitrogen-14 is because that isotope comes in at a very small percentage. And so carbon, notice it's 12.011. That means carbon-12 is extremely common. Carbon-13 and carbon-14 are extremely rare, but they're taken into this number as a term of percentage. And that is how we get mass numbers that are not truly whole numbers. Because if you think about it, neutrons have 1 AMU, or atomic mass unit. I'll just write that out. Atomic mass unit. So a neutron has 1 atomic mass unit, proton has 1 atomic mass unit, and electrons have 0 atomic mass units. So when the mass of something is, for instance, with, say, chlorine, 35.45. So chlorine being 35.45, how can just solid numbers of 1s add up to be 35.45? Well, it does come from the isotopes. So obviously, there is a higher isotope of chlorine. So chlorine, we have chlorine 35, and then there's also chlorine 37. And chlorine 35 is approximately 75% of all the chlorine, and chlorine 37 is approximately 25% of all chlorine. And so if you do the math right and figure that out, you will get, if you do just this math here, to figure out what the mass is of chlorine, you'll get something around 35.5. Because these aren't the exact values, these are just a quick estimate to help you understand how this all works. And so what you simply do is take the 35 and multiply it by 0.75, take the 37, multiply it by 0.25, and add those numbers together, and you should get 35.5. Should get, if I did my math right. And so that is the basic understanding of isotopes, and now you know where the positive charges come from as well as the negative charges in the periodic table. And that's about all to discuss on the atom for now. More might come later as I get further into chemistry. So stay tuned and I'll post more videos on the basics of chemistry.